So you guys so far have been doing a lot of work with graphs of motion, just seeing like, all right, I'm going to move this direction. What does the graph look like? I'm going to move that direction. What does the graph look like? Right? All kinds of different ways. And what does the distance graph look like? And then how can we use that information? And you've been doing it with your conjectures to find out what the what the velocity graph looks like. Okay? So we're going to take that and we're going to try and move it a little bit more to figure out what to jump up the next level to acceleration. Okay? Benji, you want to do me a favor? Grab a meter stick and just tap that thing with it. Thank you. So here's my distance graph, and it's got 3 sections. So someone did something where they were running around, right? And they moved in this motion, then they moved to here, and then they did that. And what I'd like to do is now, what does the velocity graph look like for this situation? More. Good. What does the velocity graph look like for this situation? What does the acceleration graph look like for this situation? Okay? We've already done a little bit of this, right? Translating distance to speed, correct? In your conjectures. You're going to see that what we do to go from here to here is the same going from speed to acceleration. Okay? All right, so first thing we want to do is I want to know, what does the velocity graph look like for someone that is moving with this distance graph? Okay? So first of all, let's identify what exactly is happening here. What could this person be doing to get a graph to look like this? Okay, so he's starting slow and he's speeding up. Right? So he's starting slowly and he's speeding up. So we know now what the person is doing. Okay? We've identified that. So now what we want to do is, what is that like one thing in every graph that can guide us to go to the next level? What's the one thing we have to look at? Yep, the slope of the line. Right, excellent. So if we look at the slope of the line for each segment, we'll be able to figure out what has to happen with the velocity. Okay? So the first thing, the slope of the line tells us the speed, so we're good. We know that if we look at the slope, we'll have the speed. The next thing then is, what's happening to the slope? Is it increasing, decreasing, or staying the same? It's increasing, right? So it's going from a slope like this, and as it goes along, it's getting steeper, right? So the slope is increasing. All right. So we need to show something where the person is speeding up, right? Because the slope is increasing, then the speed is increasing. Perfect. Okay. So we know we need to show someone speeding up. The next thing then is positive or negative direction? Positive direction, right? Positive slope, right? So positive direction. So I need something of VT graph. I need a velocity graph that is going to show me speeding up in the positive direction. Okay? So speeding up so positive direction means I stay in the positive half of the velocity graph, correct? So here there is no like negative part of the graph or distance graph. So if we're going to show positive direction, it needs to be up here. Negative direction would be below the graph. Okay? So I need to show that they're speeding up positive direction. So positive direction would go up here. Speeding up should show that it's increasing, or the value on this side is increasing as it goes along, right? So we're going to have something that probably looks like that, right? That's what our graph would look like for a velocity graph, right here. Does that make sense? Are we okay with this? Good to go? Natalia? All right. Good to go right here. Okay, awesome. How about for this line now? Again, looking at the slope. What's the slope of this line? 0. So very simply, what should the speed of this person be? 0, right? So where should we draw his velocity graph? On the 0 line, right? So we'll draw it. Okay? So we draw it right there. Simple. Easy. You okay, Rachel? Okay. We don't have to worry about anything else. We don't have to worry about the direction because they're not moving, right? We know the value of the slope is 0 because it's a 0 sloping line, right? We know the value of the speed. So now let's look here, and let's go again, all right? First off, positive speed, negative speed. Why negative speed? Right, the slope is negative. Okay, so we know that the person's moving in the negative region, right? Moving in the negative direction. So for velocity, they need to be in the negative region of the graph. Okay? Next thing, speeding up, slowing down, constant. Constant, right? Constant speed, negative direction. So I'm going to have a velocity that has a constant value in the negative region of the graph. Okay? So I'm just going to do this. Okay? Which you guys showed me in your reflections or your conjectures in the 3 activities we did. Okay? So here's the thing that's a little different, or something that now we need to put together. In my lower classes, we'll just draw lines, vertical lines that connect them, and say, "Yeah, that's great." College Board don't like that. Okay? They want to, the math skills that you've already learned in terms of if you have a function or you have a line, right? It needs to be continuous. Correct? So we have to do the same thing. Does it have to be perfect? Absolutely not. Okay? But it needs to show that it is continuous. So here's what I do. I just go right here, and I know it's going to connect, so I just give it a little bit of a round, a little bit of slope, and then I round it back in. Okay? And I do the same thing here. Just a little rounded, a little bit of a slope, and round it back in. Okay? So now my line is continuous. It's all connected, and we don't have 7 different values for one x. Okay? Make sense? So here's what we can look at. Now we can actually define speed. We can actually define what speed is just from looking at this graph. Okay? When does a velocity occur? What is happening in the distance graph when we get a value for velocity, for speed? What is happening up here? Yep. Your slope is either increasing or decreasing. Just now, how about in thinking just in terms of distance and position? What is happening to get these? So what's happening? You're almost there. What's happening to the position as... So it's changing, right? So it's changing. Awesome. So the only time we actually have speed is when your distance changes. Does that make sense? Okay. So then, just by looking at this, we can define speed to be the change in distance with respect to time. Does that make sense? Okay. So super simple. It's just... So very simple, very basic. The graphs have told us, right? I mean, you read it in your reading too, but the graphs have just told us, just by looking at the graphs, that speed, the definition of speed, is a change in distance with respect to time. Right? Make sense? Are we okay with that? Okay. It probably seems relatively obvious, but that's what it is. It is what it is, right? It's also a great exercise in trying to, how much information can we pull out of a graph? Okay? All right, so now I want to know, what does the acceleration graph look like? Okay? Now, you're reading, you probably read the definition of acceleration, right? But we haven't done any graph stuff with it. But I propose that the information or the technique that we use to go from here to here is the same exact technique we can use to go from here to here. Does that, you follow me? Okay? So what was the one thing we looked at to create this graph? We looked at what? Slope, right? So, let's look at slope for these sections again to create the acceleration. Okay? Make sense? Okay? Awesome. And we haven't talked about acceleration whatsoever in this class. You reading yes? In here? No. No. But they're all linked, which is pretty great. So let's look here. First, positive, I should say, increasing speed, decreasing speed, constant speed. What's going on? Increasing speed. Okay, so increasing speed. Constant rate, changing rate. Constant, right? So it's changing at a constant rate because it's a constant slope, right? Constant slope. All right, now, positive or negative? Positive. It's positive. Okay. So same thing. Constant value in the positive direction. So I need to show, for acceleration, a constant value in the positive direction. Okay? So constant value, positive direction, would look something like that. Okay? So let's look here now. What's the slope of this line? 0. So we have 0 speed. So what can we say about the acceleration? No acceleration, right? It's not accelerating because there's no slope. It's a 0 sloping line. So the acceleration is also 0. We'll just do this. And I'll do my little continuous move right there. Okay? Sorry, it's kind of hard to see. Purple and black don't always mix well. Okay? So then let's look at this piece right here. What's the slope of this line?
0.
0, right? 0 slope, so the acceleration is 0 as well. So that's actually interesting. You could have speed, but no acceleration. Right? Same thing kind of happened here. You could have distance, a position, but no speed. Okay? See how we use the same techniques? Right? We use the same ideas, the same process to go to something that we don't even know. Right? That we didn't even do. But we're able to go from one to the other using the same ideas. Right? So just like we were able to form a definition for speed by looking at the graphs, can we form a definition for acceleration just by looking at the graphs? What do you think? When did we get a value for acceleration, or when did acceleration occur? Dash?
Change in velocity over time.
Right. So acceleration is a change in speed with respect to time. Okay? So now, really the big thing, aside from drawing these graphs and translating these graphs, which you guys will pick up very quickly, and I think you already have, the big thing here is that a lot of this has to do with change, right? If there's no change, you don't get something. Right? So if you don't change your distance, you don't have speed. If you don't change your speed, you're not changing your acceleration. All right? Or you're not accelerating, I should say. Okay? Follow me? All right?